Today we are going to discuss about the electric flux and Gauss's law. আজি আমি ইলেক্ট্ৰিক ফ্লাক্স আৰু Gauss's law বিষয়ে ষ্টাডি কৰিম. We know that the electric field lines can be used to represent an electric field. আমি জানো এখন ইলেক্ট্ৰিক ফিল্ড ৰিপ্ৰেজেণ্ট কৰিবৰ কাৰণে ইলেক্ট্ৰিক ফিল্ড লাইনছৰ সহায় লোৱা হয়. What is electric field lines? Electric field lines are some imaginary path along which unit positive charge moves when it is free to do so. So yet these are the electric field lines. So in this diagram, this is electric field lines. So here all the lines are straight and parallel and equally spaced. So therefore it represents a uniform electric field. If the lines of force are curved, then it represents a non-uniform electric field. So this is all about the electric field lines. But what is the topic today? Electrostatic flux. So what is electrostatic flux? It is the flux associated with a surface placed in the electric field. So electric field is represented by lines of force. So these are the lines of force. So these are the lines of force. They represent the electric field. So in this electric field, I place an area normally. Then how many lines of force passes through it normally? 1, 2, 3. So what is flux associated with this surface at this moment? It is 3. So what is the definition? It is the total number of electric field lines that passes normally through an area when it is held in an electric field. So in this diagram, how many lines of force passes through this area? This is the area. This is the area. This area is placed in the electric field. How many lines of force passes through this area? 3. So flux linked with this surface is 3. In the figure 2, this is the electric field. This is the electric field. How many lines of force passes through it? Not a single lines of force passes through this area at this moment. So what is the flux associated with it? It is 0. Is it clear? Is it clear? So what is the definition? It is the total number of electric field lines that passes normally through an area when the area is held in the electric field. So in this diagram, these 3 lines of force passes normally through the area. So flux linked here is 3. In this figure, not a single lines of force passes through this area. So flux linked with this surface is 0. Okay. Now, if I place the area inclinedly, have you seen it? How many lines of force passes through it? It is only 2. That means, if I place the area, say this is the area, this is my area, these are the lines of force. If the lines of force passes like this, maximum flux linked with it. Say this is the area, this is the lines of force. Lines of force are like this. Then not a single lines of force passes through it. Now this is the area. Now area is inclined. Okay? So in this case, the flux linked with the surface is in between the maximum and 0 value. You just see. Here, maximum lines of force passes. Because here in this figure, 3 lines of force passes normally. In this figure, not a single lines of force passes to the area. But in this figure, how many lines of force passes? 2. So in this case, the flux linked with the surface is in between maximum and 0. There is another definition of electric flux. So what is the definition? The electric flux associated with a surface is the dot product of electric field intensity, with area vector. We know that electric field intensity is a vector quantity, but area is a scalar quantity. How it becomes the area vector? Sometimes we have to express area in terms of vector quantity. So in that case, what is the procedure? What is the method? If we draw a normal, outward normal to an area, it becomes a vector quantity. So this is the area. This is the area. Now area is scalar. But if we draw a normal like this, if I draw a normal in this direction, then this area becomes a vector quantity. So what is area? What is electric flux? The electric flux is the dot product. Since electric flux is dot product, it is a scalar quantity. Electric flux is a dot product of electric field intensity with area vector. We know that when we multiply two vectors according to the method of dot product, result is a scalar quantity. Okay? So what is phi? Phi is equal to E dot A. So since it is dot product, E A cos of theta. From the previous definition also, we can say that electric flux is a scalar quantity. Why? How many lines of force passes through this area? Only 3. How many lines of force passes through this area? 0. Since it is the number 0 and 1, electric flux is a scalar quantity. Is it okay? Now, I have given 2 definitions. Now, I want to explain these definitions with the figure. So what they say, that if we draw a outward normal to the area, it becomes a vector quantity. Now, this is the first figure. Here, 3 lines of force passes normally through the area. This is the outward normal. Have you seen it? N cap, dotted line. This is the outward normal. When I draw this outward normal to this area becomes a vector quantity along the direction of outward normal. Now, what is the angle between this n cap and E vector here? What is the angle between this n cap and E vector here? So this angle is 0. So what is phi? Phi is equal to E dot A. Phi is equal to E dot A. E dot A means E A cos of theta. What is the value of theta? 0. E A cos of 0. What is the value of cos 0? It is 1. So E A. That means here maximum flux linked with the area. In this figure also, how many lines of force? 3 lines of force. So maximum flux linked with this area. Is it okay? Now in the figure 2, this is the area. If I draw the outward normal in this direction, the area is like this. So if I draw the outward normal, this is the outward normal. So here this is the outward normal. In the first case, this is the outward normal because area is like this. Area is like this. This is the outward normal. Now area is like this. This is the outward normal. So what is the angle between outward normal and E vector here? It is 90. It is 90. What is the value of cos 90? Cos 90 is equal to 0. Cos 0 is equal to 1. So what is flux associated with it? Phi is equal to E dot A. E A cos of 90 is equal to 0. So in this figure also, according to the first definition also, electric flux associated with the surface is 0. So here also, electric flux associated with the surface is equal to 0. So it is a mathematical definition and previous one is an analytical definition. Now if the area is held inclinedly, so this is the direction of outward normal, this is the direction of E. What is the angle between them? Theta. This theta is in between 0 and 90. I can say this is acute angle. So if theta is less than 90 degree, value of cos theta is equal to positive. So what is the flux linked with it? It is in between maximum and zero value. Okay? Is it clear? Next it comes, what is the dimension of electric flux? What is the dimension of electric flux? So this is the definition, E dot A or EA cos of theta. We know that cos theta has no dimension. So phi is equal to EA, dimension of E into dimension of A. This A means area. What is E? What is electric field intensity? Force on unit positive charge. Therefore, E is equal to F by Q. A means area. What is F? M1 L1 T to the power minus 2. What is Q? Charge is not fundamental. What is the dimension of charge? A1 T1. This A is current. This A was area. Area means L square. So what is M1 L cube T to the power minus 3 A to the power minus 1. The dimension of electric field intensity is already given to you in the definition of electric field intensity. মই আজি তোমালোকক ইয়াত আৰু এবাৰ উলাই দিছো. I again derived the dimension of electric field in this class. E means F by Q. F is M1 L1 T to the power minus 2. What is Q? Dimension of Q is not Q1. Charge is not fundamental. So it is current into time. Therefore A1 T1. And what is this A? This is area. Area means L square. So dimension of electric flux is M1 L cube T to the power minus 3 A to the power minus 1. Okay, is it clear? What is SI unit of electric flux now? What is SI unit of electric field intensity? It is Newton per coulomb. What is SI unit of area? It is meter square. Because cos theta has no unit and dimension. What is phi? EA. What is SI unit of E? Newton per coulomb. What is SI unit of area? It is meter square. So Newton meter square per coulomb. But this can be written as Newton meter into meter. Meter square, meter into meter. What is Newton meter? Newton meter is joule. That means Newton meter square per coulomb can be written as joule meter per coulomb. Joule meter per coulomb. What is joule per coulomb? Joule per coulomb is volt. So what is SI unit of electric flux? It is volt into meter. What is SI unit of electric flux? It is volt into meter. Okay? Sometimes in the exam, they asked, what physical quantity voltmeter represents? Voltmeter represents the SI unit of electrostatic flux. Is it clear? Is it clear? Now, we return back to the actual definition of Gauss's law of electrostatics. There is another Gauss's law that is called Gauss's law of magnetostatics. That law we discussed in the chapter called the magnetism. What is the Gauss's law? G-A-U-S-S. Sometimes it is pronounced as Gauss's law. The total electric flux linked or associated with a closed surface in air medium is equal to 1 by epsilon 0 times the total charge enclosed by the closed surface. What is Gauss's law? The total electric flux linked with a closed surface. This word is very important, closed surface. In the previous case, when we give the definition of electric flux, I never put the word closed. Electric flux associated with a surface is the dot product of intensity with area vector. I never give the word called the closed. Okay? Is it clear? This area of my hand is called the open area. But what is the closed area? This is the closed area. If I hold the two hands like this, you just see. So inside my two hands, some area is there. Inside my two hands, some area is there. This area is called the closed area. I can give another example. At this moment, I have this container. Okay, this container. This is one surface, curved surface. This is one. So inside this container, some volume is there. You don't see the substance inside the container. Okay. So inside the container, some volume is there. Then this surface is called the closed surface. Okay. That means Gauss's law is not applicable for the open surface. Open surface means this surface. The surface which does not enclose any volume. The total electric flux linked with a closed surface in air medium is equal to 1 by epsilon 0 times the total charge enclosed by the closed surface. Gauss's law always applied to the closed surface. Closed surface means it is the surface which encloses a volume inside it. So in that closed surface, what is electric flux? What is the magnitude of electric flux? The magnitude of electric flux is 1 by epsilon 0 times total charge enclosed by the closed surface, provided closed surface is in air medium. What is this symbol? It is called permittivity of free space. It is a fixed value, 8.85 into 10 to the power minus 12. Can you remember? Coulomb square divided by Newton meter square. What is this? It is called permittivity of the free space. 8.854 into 10 to the power minus 12. Coulomb square divided by Newton meter square. Okay? So phi is equal to Q by epsilon 0. But what is this symbol? When this symbol appears, the students get confused. But it is nothing but, it is simply a mathematical representation. What is electric flux? Already we have written it is the dot product of electric field intensity with area vector. Okay? So you just see, it is the electric field intensity. This is ds means area, s for surface, ds means small surface. So why the small surface? Here it is confusing. No? Here phi is equal to E dot A or E dot S. This may be written like this. Here it may be written like this also, E dot S. It may be written like this, E dot S also. Phi is equal to. But here we take the ds. What is the logic behind it? So whenever the area is a large area, instead of calculating electric flux at a time for the whole area, we divide the whole area into small elementary areas, each of area ds. Gutei surface khonok ami horu large number of area divide kuru. Hey horu area khonoke ds buli koise. Gutei dangor area khonok moi horu area bhag kuri loisu. Ita eikhon dangor area asil, ekhon horu area eikhon hobo pare, ekhon horu area eikhon hobo pare, ekhon horu area ei curve tu hobo pare, curve surface tu hobo pare. Then I calculate total electric flux. So I calculate electric flux associated with each and every area individually. Okay? Then I have to add it. Add means the integration. What I am adding? I am adding electric flux associated with different surfaces. Therefore, this S is put here. Okay? Now, why this circle represent here. This circle represents it is a closed surface. My surface is closed surface. That closed is given by this circle. This S represents I add the electric flux associated with different surfaces of the closed surface. Okay, is it clear? কথাটো এনেকেও ভাবিব পাৰোঁ, আমি যেতিয়া ভাত খাওঁ, আমি ভাতৰ লগত কি থাকে? ৰাইচ থাকে, ডাল থাকে, মাটন থাকে, ফিছ থাকে. The eating process, during the eating process, we never eat all the items at a single time. We normally divided the eating process in large number of steps. Small amount of rice with dal, small amount of rice with mutton, small amount of rice with fish. We never eat fish, mutton, dal at a time. Yes or no? So here also, whenever a large closed surface is there, the procedure is we have to divide the entire closed surface. We have to divide the entire closed surface into large number of elementary areas, each of area ds. এতিয়া চোৱা, এইটো এটা ক্লোজ সাৰফেস, এইটো এটা ক্লোজ সাৰফেস, এটা স্ফেৰিকেল সাৰফেস এটা আছে, ভিতৰত এটা চাৰ্জ কিউ আছে. So depending on this charge, lines of force comes out of it. This charge is positive, therefore lines of force are moving away from it. So I divide the entire closed surface. Into large number of elementary area each of ds. Now you just see through this surface, elementary surface line, this is the direction of electric field intensity, this is the direction of outward normal. So what is the flux associated with it? It is E dot ds is E ds cos of theta. So in this way, through every surface, elementary surface, ইয়াৰ মাজেৰেও এটা flux পাম. Through this surface also one flux passes, one lines of force passes, one flux is there. I have not represent here. So through the entire small elementary areas, I calculate the flux and then I add it up. And that adding is this closed integration. Okay, is it clear? Now, a little bit of small important points. If a closed surface encloses positive charge, flux linked is positive or outward. If a closed surface encloses negative charge, the flux linked is negative or inward. If a closed surface placed in uniform electric field, but no charge is inside it, net flux linked with the closed surface is equal to 0. A closed surface is placed in uniform electric field, but inside the closed surface no charge is there. The net electric flux linked with the surface is equal to 0. And if a closed surface encloses a 1 coulomb positive charge inside it, 1 coulomb positive charge inside a closed surface, what is the flux? 1 coulomb by epsilon 0, 1 by, this is the value of epsilon 0, we will get 1.129 into 10 to the power 11 Newton meter square per coulomb. So, Marolov repeat kori disu, if a closed surface encloses positive charge, flux linked is positive. If a closed surface encloses negative charge, flux linked is negative. Or if a closed surface encloses no charge, but placed in electric field, flux linked is equal to 0. Today, I stopped here.